Hi everyone, my name is Shashankan. Today we are going to see about some fundamental concepts of register transfer. What is register transfer? Basically, transferring the data from one register to other register is called the register transfer. Let us see the definition of it. The register transfer is the availability of hardware logic circuit that can perform a given microoperation, transfer the result of the operation to the same or another register. Okay. Register transfer are the movement of data between the register in the digital system. They are the fundamental part of the architecture of computer and digital design. Register transfer enable the processing and manipulation of data within the system. We can manipulate the data present in the register by using the register transfer. Data can move from one register to other register, and it can be manipulated using various logic operations or arithmetic operations. Let's see the block diagram. We are moving the data from one register to other register using a control unit of signal load and passing the clock signal. Let us see the purpose of register transfer. First purpose is the data movement. In order to move the data from one register to other register, we use the data movement registers. Let us see the definition of it. Register transfer are primarily used for moving data between different registers within the CPU or between the CPU or between register and memory. This movement of data is essential for executing instructions, performing calculations, transferring data between components of the computer system. Second one is the instruction execution. Register transfer are a crucial part of the instruction execution process because instruction execution, the instructions are fetched from memory and then are decoded. The operands are transferred between the registers before the operation is performed. So, in order to perform an operation, first the data or the number, let us see the data is number, it should be transferred from one operand from one register to other register where it performs the micro operation and transfer the result to the memory. So this transfer ensure that the data required for executing instructions are available in the appropriate registers. It ensures the data available in the executing instruction. Next one is the control flow. Register transfer are used to manage the control flow in a computer program. Let us take an example. When a branch execution is executed, register transfer may be used to update the program counter within the address of next instruction to be executed. First of all, let us say that there are few lines of code. We are executing one of the line of code. The next line of the code or the address of the next line are has to be updated as the code runs. This work has done by the register transfer or register transfer control flow. Next one is the data processing. Register transfer enable the data processing operations such as arithmetic, logical operation, data manipulation, or data transformation. Data stored in register can be manipulated using register transfer to perform various computation tasks. Let us see there are two registers R1 and R2 and we have to add between two registers. Let us take an example that R1 contains a number 3 data 3 and R2 contains a number 4. We have to add between two registers, so the resultant operation is stored in the another register or within the same register. So resultant is 4 plus 3 7, that is to be recorded in the register 3 or within the same register. I earlier said that it is used in the data storage. Registers serve as a temporary storage allocations for data during the program execution. Registers are used to load the data into register from memory, as I said, and store data from memory register back into the memory. Let us take an example that we are performing an operation. For performing our operation, we require register because registers store the data and perform the operation. First of all, we load the data from memory to the register to perform an operation. Later, after performing operation, we fetch the data from register and store back to the memory. It is used in the that means registers are used to transfer the data between the memory and register. Types of register transfer. First one is data transfer. To transfer data, there are some register which perform this operation. This type of register transfer involves the movement of data from one register to another register. It can include the transfer of data between general purpose register, between register memory, as I said before, and between the different components within the CPU. Load and store. To perform the load and store operation, there are a set of register transfers which performs the load and store operations. Load and store operation involves in the transferring the data from memory and register, between the memory and register. A load operation transfers data from memory to register, while a store operation transfers data from register to the memory after the micro operations. Control transfer. Control transfer is the control operation involve transferring the control from one part of the program to another. This includes the transferring control to a subroutine or function, branching to a different part of the program based on the condition, or returning from a subroutine. We have to control, or the transfer the control of a program to another register which performs the operation. It is next one is the stack operation. Stack operation involves pushing the data into the stack or popping the data from the stack. For this operation, we use the registers or register transfers, let us say technically. These operations are commonly used for the implementing function calls, managing local variables, preserving the state of the program during subroutine calls. The data flow in the register. How the data flow is in the register. Let us see what are the things happens in the data flow in registers. Data movement between registers. The data is flowed between the registers, as I said earlier, or between the register memory and where it and get operated arithmetically or logically. Let us see the one by one. Data movement between register. The primary function of register is to store the data temporarily, okay, during the program execution. As okay. Next, data flow often involves transferring data between register within the CPU. In order to perform a certain operation or execute a program, the data has to be transferred from one register to other register, or it has to be transformed between register and CPU. Because in CPU we get a signal called load signal, where it is get the uh, based on certain condition we get the load signal in order to perform the certain operations. Next one, data transfer between register and memory. As I said before, register transfer also involve moving data between registers and memory. When the data is needed from memory, it is loaded. After computation of task, again it is back loaded, and again it is back or reloaded to the memory. Arithmetic and logic operations. In the registers, we are going to perform various operations like arithmetic and logical operations. Data stored in registers is manipulated using arithmetic operations such as addition, subtraction, multiplication, division, such as well as we can do the logical operations such as OR, AND, XOR, shift operations, NOR operation, in order to manipulate the data which is present in the register. Next one, the control transfer and data flow. Control transfer instruction, such as branches and jumps, can also involve data flow. These instructions can change the flow of the execution within a program based on certain condition. If the condition is true, it it executes a certain set of instructions or control the execution. That's why I share the control transfer and data flow. It is a let us see the register transfer language. Register transfer language is a description or the language used in the digital circuit design. It is primarily used to describe the flow of data within the digital system at a low level of abstraction. It includes mainly four type of languages. First includes parentheses, letters, arrow marks, and comma. Let us see the one by one, or let us see the level of abstraction. Abstraction. RTL operates at a low level of abstraction compared to the higher level hardware such as VHDL, Verilog. It is RTL is a very low level language, or it is a basic level of language compared to the higher level language such as VHDL and Verilog. It is closer to the level of underlying hardware implementation. Okay. Data flow specifications. RTL describes the flow of data between registers by specifying the operations. As I say, operation. It has plus operator, minus operator, or AND operator. By using specific operations, we are manipulating the data and transferring to the another register. Sequential logic. RTL descriptions how often involved in the sequential logic, where the where the behavior of system depends on the current state as well as the input data. With the behavior of the system depends on the current state as well as the input data. Digital verification. RTL describes or RTL descriptions are used extensively in the process of designing and verifying digital circuits. Designers can stimulate the behavior of system in RTL to ensure it meets the desired functionality and performance enhancement. It verifies the design implementation and the design of the logic circuit. It basically verifies the designing and verification of logic circuits or digital circuits present in the various registers. Let us see the transfer languages. Transfer language is basically what I said. It is it used to describe the flow of data within the digital system or between the two registers. It includes letters, parentheses, arrow marks, and commas. Parentheses is used to describe the part of register, and letters is used to describe the name of the register. Arrow mark used to describe the how the data flow direction is going on, and the last one I said comma used to describe how many registers are present and how it operates. Let's see the next slide. In order to perform the operation, we require a signal, some control signals. Based on this control signal, we can go further or to perform the operation or to transfer data from one register to other register. Let us see the control signals. Control signals in the context of register transfer language, these signals are responsible for coordinating various activities within the circuits, such as enabling, disabling the operation, selecting between different data paths, and controlling the sequence of operations. Control signals, they synchronize the timings of operation within circuit, ensuring that different components of operator in a coordinate manner. It ensures the it ensures the different components operate in the coordinate manner. It includes synchronous circuits. Operations often occur in the rising or falling edge. It includes the rising edge 1 and falling edge 0. Between 0 and 1 it plays. Next one is the enable signal. To perform an operation, just say in the flip flops, JK flip flops, we use a signal called enable signal or enable pin. Because of this enable signal, they are going to activate or deactivate specific components or operation within the circuits. Control signal for multiplexers. Multiplexer or muses are used to select between multiple input data source based on the control signal. Control signal are used to specify which input is routed to the output of the multiplexer. Basically, we have three selected lines, 0, 1, 2, and we have the input lines and we have the output lines. These control signals are control the operation of the registers. Status signal. Status signal conveys the information about current state of the circuit of the result of the register transfer operation. It tells the which the register. It tells about the current state or the present state of the register transfer operation. Is reset signal. Reset signal are used to reinitialize or initialize to the start of the program where computer can detect or start the program from beginning. Let us see the definition of it. Reset signal are used to initialize the state of the circuit to a known state. What I say, it initializes the circuit present in a different state to the known state. They are commonly used to ensure that registers start in a predictable state. This they ensure that registers start in a predictable state when the system is powered off or on. Synchronous and asynchronous register transfers. It is basically between let us see the definition of it. Synchronous register transfer used to transfer data occur simultaneously within a clock signal. The data is uniform between one signal to another. Let us see the diagram of it. See, the data is uniform. After one time, after 1 unit, it again rises, and after 1 second, it again fall. This uniformity is present in the synchronous register transfer. In asynchronous register transfer, data transfer that occur without being synchronized to a clock signal. See, if a signal is getting high, after some time it get low, but this time duration is not specific or not constant in the upcoming time. It take 2 seconds, again it take 3 seconds or 4 seconds. It is not uniform. That's why I said asynchronous. Asynchronous or synchronous data are commonly used in the modern computer system for their simplicity and reliability. Let us see the micro operation on register transfer. Micro operation are fundamental building blocks in the execution of machine instruction and operation of processor. Micro operation are the operation or the program used to executed in the register, or the operation that are performed in the register are called micro operations. Let us see the what are operations that perform in the register. Data transfer operation. These operations involved in the moving of data between register or between register and memory include loading data from memory to register and storing the data from register to memory. Simple. Arithmetic micro operations. Arithmetic micro operations involve performing arithmetic operations such as addition, subtraction, multiplication, and division. Logic micro operations. Logic micro operations involve performing logical operations such as AND, OR, NOT, shift, NOR, and store the resultant or data or output into the another register, or storing within the same register. Let us see the control micro operation. Control micro operation involve modifying control signals within a digital system to control the operation. Examples include setting or resetting control flags, enabling, disabling. In order to control the operation, micro operation, we use a certain signals. Before I said, see earlier, control signals, enabling signals, such as register transfer example. Let's see the examples of it. Transfer contents. Let us see, first take an example one. Transfer the contents of register A to B. Contents of transfer from A to B. Let's see the understand the block diagram. In order to perform a certain operation, there will be a condition. If this condition is true, the control unit produces a signal called load signal to the R2 register, and a clock signal present in order to perform a certain time. The data stored in the R1 are transferred to the R2 if the condition is true. That's what it said. Transfer the contents of a register A to B. Second example, add the contents of register A and B and store result in C. Let us take an example of R1 and R2. In order to perform an operation, micro operation between the two operators, between two registers, A and or R1 and R2, the resultant is stored in the another operator R3 or C. Yeah, we say C. Perform a logical and operation between the contents of register A and B and store the result in this register D. Here we did the arithmetic operation. If you do the same operation or logic operation between the those two register, we store in the another register in D. Using C, we have the load signal and clock signal. Let us see the next slide. Let us see the conclusion part of the what we have saw till now. In conclusion, register transfer are fundamental aspects of digital computer and architecture and digital design. Yes, okay. They involve in the movement of data between register within a digital system, typically facilitated by micro operation. Basically, register transfer is the transferring the data from one register to the other register and performing certain micro operation between those two registers and storing the result into the another register or within the same register. Register transfer is essential for executing machine instruction, performing arithmetic and logical operations, okay, and controlling operation in the digital circuits. Register transfer language RTL provides symbolic annotation for specifying the data flow. It tells how the data flow direction. It tells about direction or the name of the register or number of registers and part of register. It tells the where the data is moving from one register to another register, how the data is moving. It tells the how it describes the data flow in the register transfer. Thank you.